Hello children, how are you all? Hope you all are fine. Okay, in the previous class we have studied about what we have gone through the metallurgy. Okay, unit 1 metallurgy, concentration of ore, extraction of crude metal, refining of crude metal. Okay, in the last class I have told you to study about the application of aluminium, zinc, okay, iron, copper, gold. Have you studied it? Okay, I am believing that you have studied. Okay, soon we will call you for exams and all. Okay, you should be ready for everything. Okay, okay, every time you go through with each and every day what we are taughting you. Okay, you go through with all the subjects. Okay, okay, give importance to physics, chemistry and maths. Okay, that is a very important subject in your 12th standard. Okay, now today in unit 2 we are going to study about p block elements. Okay, p block elements. Okay, what are p block elements? Okay, have you studied in 11th standard the periodic table? Okay, in periodic table, okay, there are, okay, we have already studied about the classification of elements. It is classified into 4 blocks, that is S block, P block, D block and F block. Okay, there are 4 blocks. Okay, so we have also learned the properties of S block elements and their important compounds in the 11th standard. Okay, do you remember that one? In the previous 11th standard you have studied about the 4 blocks, S block, P block, D block and F block. Okay, so in this year we are going to learn the remaining blocks, that starting with P block elements. Okay, P block elements. Okay, what are P block elements? I will tell you. Okay, the P block element is very interesting element. Okay, in this P block element there are lot of elements. Okay, lot of elements. Metals are there, non-metals are there, metalloids are there. Very interesting elements are situated in P block elements. Okay, you should be very interested and very keen to study about the periodic table. Okay, okay, take the periodic table with you. Okay, are you having periodic table in your book only? Yes, P block elements are given in this chapter. Okay, okay, in the previous books in 11th standard I think you may having the periodic tables. Okay, now I will explain about the periodic table. Okay, yeah, see here, this is the periodic table. Have you seen the periodic table before? Yes, of course, in your 11th standard you have saw this periodic table. Okay, there are 4 blocks. Okay, S block, P block, D block and F block. Okay, right. Today now we are going to see the first 2 groups, group 1, group 2. There are 18 groups, 1, 2, 3, 4, 5 up to 18 groups. That 1 group and 2 group, and the last one 18 group, the first one. Okay, that is the S block elements. The pink color elements is given, no, that is D block. The sky blue color is given, that is the P block. So in this lesson we are going to see about the elements that is in the sky blue color, that is B, C, N, O. Okay, are you seeing? That is the P block element. The pink color is D block element. Okay, and the light violet color, light lavender, that is F block elements. Okay children, this is the periodic table. In the periodic table there is the element. Okay, there is the element, its atomic number, mass number. Okay, you can study and go through the periodic table. Okay, you should remember the periodic table, what elements are in S block elements, what elements are in P block elements, what elements are in G block elements and what are in F block elements. Okay, you should go through with it. Okay, this is the periodic table. In this periodic table we are going to see about P block elements. Okay children, now there are general trends in the properties of P block elements. Okay, what is P block elements? Okay, there are general trends in the P block elements. I will tell you one by one. Okay, in the previous picture I have shown you the periodic. In the periodic table I have shown you the P block elements. Okay, P block elements. So what is a P block element? The elements in which their last electron enters the p orbital. Okay, K, L, M, N, O, P. Okay, that is the orbitals. Okay, that is the orbitals. The electron which enters the p orbital okay, that constitute the p block. எந்த elements-லாம் p block-ல இருக்குதோ அதோட last electron p orbital-ல இருக்கும். That's all, okay. So they are placed in the 13th to 18th group. That are placed to 13th to 18th group, okay. See here, group name given and மேல வந்து group number 13, 14, 15, 16, 17, 18. In 13th group, okay, in 13th group, the last orbit la there will be 3 electron, and 14, that is last la 14, and 15 means in the last shell there is 5. In 16th group la irukra ella elements layum last valence la 6 electrons irukum. Do you understood? Okay, these are the general trends in the properties of p block elements. Okay children, have you understood? Right. Now they are placed in 13th to 18th group of modern periodic table, and the first member of the groups are boron, carbon, nitrogen, oxygen, okay, fluorine, helium respectively. They are the first member of the groups 13th to 18, that are icosagens, tetragens, pnictogens, chalcogens, halogens, inert gases, okay. Their outer configuration are ns2 np1, and for 14th group the electronic configuration is ns2 np2, and for pnictogens ns2 np3, like that. So the ns2 will be same, but p value np1, np2, np3, np4, np5, np6, that only changes, okay. Highest oxidation state, that is the group oxidation state. For 13, that is +3. I told you, no, in the last valence shell there is 3 electrons, so +3, and 14 means +4, 15 means +5, 16 means +6, and 18 is the +8. That is the last configuration. It is fulfilled. So 2, 8, 18, that is the or full form la irukum, okay. So inert gases are in full form, okay. Further, the other observed oxidation states are +1, +2, -4, +3, -3, +4, the 6 is written as +4, +2, -2. You understood? These are the electronic configurations and oxidation states of p block elements, okay. Now we will tell you about the metallic nature. See here in the picture, this is the what p block elements. This is the p block element, okay. They are placed in 13th to 18th group of the periodic table, and the first member of the groups are what? Boron, carbon, nitrogen, oxygen, fluorine, and helium, okay. These are the first members, okay. So these elements have a quite varied properties, because this block, in the block la mattum da matta block la some metals mattum irukum alladhu non metals mattum irukum, but in this p block elements metals irukku, metalloids irukku, non metals irukku, inert gases irukku, okay. It contains every varieties of metals, okay. So நம்ம day to day lifeல யூஸ் பண்ணக்கூடிய அதிகமான metals p block metals தான். நம்ம earth crustல இருக்கக்கூடிய நிறைய metals p block metals தான். So in history, okay, history in previous years also அதிகமாக யூஸ் ஆன metals எதுதான்? p block elements. So this p block elements is very special elements, okay. So we should be very interesting in studying this p block elements, okay. So these elements have a quite varied properties. This block contains non-metals also, metals also, metalloids. So metals ku ஒரு property இருக்கும், metalloids ku ஒரு property இருக்கும், okay. Non-metals ku ஒரு property இருக்கும். So different properties are in this p block element, okay. So the element of this block and their compounds play an important role in our day to day life. For example, without oxygen we cannot survive, okay. Oxygen is there in this one. So without oxygen we cannot imagine our survival. We cannot live. So oxygen is very important element, okay. So the most abundant metal aluminium and its alloys have plenty of applications, ranging from household utensils to aircraft. The semiconducting nature of elements such as silicon, germanium, they have made a revolutionary change in the field of modern electronics, okay. See here, arsenic is there. Arsenic is a very poisonous element. Some paints, okay, in some paints, in previous year, they are mixing arsenic, okay. So, that arsenium, germanic, antimony, அதெல்லாம் ஒரு புரட்சியை உண்டாக்கக்கூடிய ஒரு எலமெண்ட்ஸ்னு சொல்லலாம் in modern electronics. So, these p block elements are very special elements, okay. Here, the bromine, okay, the bromine is in soft liquid form, okay. In d block elements, mercury is in liquid form. Rest of all are in solid state, okay. Helium are in gaseous form. Helium la organescent, the last one Og, that is only in solid form. Rest all the inert gases, helium, neon, argon, krypton, xenon, radon, they all in gaseous forms, okay. The metals are in blue color, metalloids are in green color, non-metal is in violet color, and the last one radioactive, NH, okay, nihonium, flerovium, moscovium, livermorium, tennessine, organeson, okay. These all are radioactive. In the radioactive metals ku vandu innum properties kandupidikala, they are under what innum experiment la poyittu irukku. So on the last radioactive patti avlo details vandu nama subject la padikave maatom, because the experiment is still going on. Our further generation will study about it, okay. Rest ella metals, non metals, metalloids patti la namakku ella ideas and properties and experiments have conducted, and we will study about it, okay children. Now, what is the, we have seen the electronic configuration. What is the electronic configuration? NS2 NP1, NS2 NP2, NS2 NP3, NS2 NP4, NS2 NP5. These are the electronic configuration to the group 13, 14, 15, 16, 17. Okay. Now, what is the metallic nature? What is the metallic nature? The tendency of the element to form a cation. Okay. To form a cation, they have to lose electron. Or cation form pananuna, there should be loss of electrons. That is known as electropositive or metallic character, okay. So this character depends upon the ionization energy, okay. So generally on descending a group, the ionization energy decreases and metallic character increases. Ionization energy decreases and metallic character increases, okay. Metallic character eppadi increase ஆகுது, ionization energy decrease ஆச்சுனா metallic character increase ஆகும், okay. So in p block elements, the elements present in lower part of the metals, see the picture. In the p block element, the elements which is present in the lower part are metals. Lower part la irukkiradhu ellame enadha metals, okay, while the elements in the upper part are non metals. Center la irukkiradhu metalloid, okay. So elements of the group 13 which is having metallic character except the first element boron. Boron thavara everyone, aluminium irukattum, gallium irukattum, okay, that everyone is a metal. Boron thavara meedi ellame enadha metals, okay. So what the metallic character, okay, group 13 have the metallic character except the first element boron, which is a metalloid. Boron is a metalloid, that is having the properties intermediate. Metalloid na enna appadina, it will have the properties of both metal and non-metal. That is the metalloid, that's all. Because at the center la irukkuradha, metal oda properties also there, metalloid oda properties non-metals oda properties also there. So metals and non-metals properties are combined together. So that is called what? Metalloids, okay. The atomic radius of boron is very small, okay. So it is having a high nuclear charge. These properties are responsible for non-metallic character. So in the groups, the non-metallic character increases. In group 14 elements, carbon is a non-metal, while silicon and germanium are metalloids. Group 14 elements, see, carbon mattu enadhu non-metal, meedi rendu metalloids, meedi rendu non-metal. So group 15 ku vaanga, nitrogen and phosphorus are non-metals, rest two are metalloids, and final one is metal, like that. So all the elements of group 17 and 18 are non-metals except only one metalloid is there, okay. Tellurium is a metalloid, okay children, have you understood? Now what is the ionization enthalpy? How is the ionization enthalpy? So we have already learnt that we move down a group, generally there is a steady decrease in ionization enthalpy. There is a steady decrease in ionization enthalpy of elements due to increase in their atomic radius. So in p block elements there are some minor deviations to this general trend. So in group 13, from boron to aluminium, the ionization enthalpy decreases. But from aluminium to thallium there is only a marginal difference. From aluminium to thallium there is only marginal difference. So this is due to the presence of inner D and F electrons, which has poor shielding effect compared to S and P electrons. So as a result, the effective nuclear charge on the valence electron increases. A similar trend is also observed in the group 14. So the remaining groups 15 to 18, it followed the general trend. So in this group, ionization enthalpy decreases. So as we move down the group, ionization enthalpy decreases. So poor shielding effect of D and F electrons are overcome by increasing the shielding effect of additional P electrons. The ionization enthalpy of elements in successive group is higher than the corresponding elements of previous group is expected. You understood? Ionization enthalpy in successive groups is higher than the corresponding element of the previous group, as per our expectation. So group 18 are noble gases, group 17 are halogens. Okay. The inert gases, that is called noble gases. Okay. That is not combined with anyone. That is a noble one. Okay. It will never combine with anyone. Okay. Now what is electronegativity? So as we move down the group 13, okay, 13th group ku ponona, electronegativity first decreases from boron to aluminium. Electronegativity decreases. Further, it increases from gallium. Okay, boron to aluminium electronegativity decreases and increases for gallium. Thereafter, there is no appreciable change. Okay, so similar trend is also observed in 14th group as well. So in other groups, as we move down the group, electronegativity decreases. This observed trend can be correlated with their atomic radius. Okay, children, do you understood what is electronegativity? Electronegativity, due to the small size, okay, the element of this group are slightly more. The element of this group are slightly more electronegative than the corresponding group 13th element. See, there is a graph, electronegativity. Okay, for carbon, electronegativity increases. For silicon, decreases. Germanium increases. Okay, lead, it is increases more. So the electronegativity decreases as we move down the group, but not after silicon. Silicon kapra enna avudhu increase agudhu, isn't it? Carbon kapra silicon apra increase apra appdi irukku. Okay, so the electronegativity decreases as we move down the group. You understood? Due to the small size, the element of this group are more electronegative. Now, anomalous properties of first elements. Okay, in p block element, the first member of each group differs from other elements of corresponding group. Okay, in p block elements, the first member of each group differs from other elements of the corresponding groups. The following factors are responsible for this anomalous behavior. Okay, in p block element, the first member of each group differs from other elements of the corresponding group. The following factors are responsible for this anomalous behavior. First of all, small size of the first number. Further, higher ionization enthalpy and high electronegativity. Ionization enthalpy is high, electronegativity is also high. Further, what happens? Absence of d orbitals in their valence shell. So these factors are responsible for the anomalous behavior. Okay, p block elements la irukkudiya first member anomalous behavior ah irukku. The behavior is very different because it is the small size. Okay, first member இருக்கிறதுனால the small size. So அதுக்கப்புறம் என்ன இருக்குன்னா electronegativity ஹையா இருக்கு, ionization energy enthalpy ஹையா இருக்கு. அதுக்கப்புறம் d orbitals இருக்காது, sp d no, so d orbitals இருக்காது. So absence of d orbitals in their valence shell. So due to this properties only, the first members of each groups are having anomalous behavior. Okay, so the first member of the group 13, okay, is a boron, that is a metalloid, while other are reactive metals. Moreover, boron shows diagonal relationship with silicon group. Okay, you can see the picture in the periodic table. Boron will have a diagonal relationship with silicon with the group 14. So the oxides of boron and silicon are similar in their acidic nature. Oxides of boron and silicon are similar in their acidic nature. So both boron and silicon form covalent hydrides that can be easily hydrolyzed. So similarly, except boron trifluoride, halides of both elements are readily hydrolyzed. Okay. And what happens in group 14? Okay, in group 14, the first element carbon is strictly a non-metal. Group 14 and the first element carbon, no, that is a strictly non-metal, while other elements are metalloids, silicon, germanium, okay, and metals such as tin, lead, they are non-metal. Unlike other elements of the group, carbon can form a multiple bonds such as C, O, like that. So carbon has a greater tendency to form chain of bond with itself or with other atoms. That process is called catenation. Okay, catenation will be a 2-mark question. Okay, that process is called catenation. So therefore it is considerable decrease in the catenation property. So carbon kapro silicon, that is adukapro germanium, and germanic kapro tin, adukapro lead, like that. Okay, so in group 15 also the first element nitrogen differs from the rest of the element. Okay, because like carbon, nitrogen can form multiple bonds. Nitrogen is a diatomic gas unlike other members of the group. So similarly in group 16, first element oxygen also exists as a diatomic gas in that group. So due to its high electronegativity, it forms hydrogen bonds. The first element of group 17, okay, fluorine, the most electronegative element, also behave quite differently compared to the rest. So idhula enna therudhapna, first element is also always behaving as a anomalous nature due to the properties. Okay, next, inert pair effect. Inert pair effect, what is inert pair effect? The phenomenon of electrons, okay, phenomenon of electrons remaining paired in valence shell. Valence shell இருக்கக்கூடிய remaining electrons that is combining with each other, that is called inert pair. It is the reluctance of the s electron of the valence shell to take part in bonding. It occurs due to poor or ineffective shielding of ns2 electrons of the valence shell by intervening d and f electrons. So it increases the group and thus lower elements of the group exhibit lower oxidation states. Lower oxidation states. Okay children, have you understood? We have already learned that alkali and alkaline earth metals have an oxidation state of +1 and +2. +1 and +2, that are alkali and alkaline earth metals, corresponding to the total number of electrons present in them. So similarly, elements of p block also show the oxidation states corresponding to the maximum number of electrons. Okay, maximum number. For example, aluminium is more stable than aluminium +1. Al +3 is more stable than Al +1. Okay, Ti +1 is more stable than Ti +3. So aluminium chloride is stable, whereas thallium chloride is highly unstable. Thallium chloride is unstable. So these are the disproportionalities of thallium chloride and chlorine gas. Okay, this effect is observed in the group 14, 15 and 16. Okay, this is the inert pair effect. Now, what is the allotrophism in p block element? What is allotrophism? Okay, some elements exist in more than one crystalline form or molecular form in same physical state. Okay, for example, carbon exists as diamond and graphite. Carbon exists as diamond and graphite. So this phenomenon is called allotrophism. This phenomenon is called allotrophism. In Greek, allos means another and trop means change. Allos means another, trop means change, so another, change, and the different forms of an element are called allotropes. So many p block elements show allotrophism. What is allotrophism? Some elements exist in one form or more form in Ore state. Physical state they are living in a physical state but showing different forms, crystalline, molecular, like that they are showing different forms. These are the allotrophism in p block element. Allotrophism in p block element. See here some allotropic forms are given. Okay, first you are taking the element boron, okay. Most common allotropes of amorphous boron, alpha rhombohedral boron. Okay, boron is in physical state, but in that physical state they are forming the crystalline forms and molecular forms. Okay, carbon is also having the crystalline forms. See diamond, graphite, graphene, fullerenes, carbon nanotubes. Okay, இது எல்லாமே கார்பன் தான். ஒரு டைமண்ட் எடுத்துக்கிட்டோம்னா இது வந்து கார்பன் crystalline form like that. So சிலிக்கான் எடுத்துக்கிட்டோம்னா அது amorphous silicon சொல்லலாம், crystalline silicon சொல்லலாம். ஜெர்மானியம்லயும் டைப்ஸ் இருக்கு, ஆல்ஃபா ஜெர்மானியம், பீட்டா ஜெர்மானியம். கார்பனா இது மட்டும் தான் கார்பன் அப்படி கிடையாது, கோல் மட்டும் தான் கார்பன் like that. It's not like that. That diamond is also a carbon. Okay, coal is also a carbon, graphite is also a carbon. So these are the various forms of carbon. That is called allotrophism. Now see here, germanium is alpha germanium, beta germanium. Tin is called grey tin, white tin, rhombic tin, sigma tin. Phosphorus is also classified as white phosphorus, red phosphorus, scarlet phosphorus, violet phosphorus, see black phosphorus. Arsenic is in various forms, yellow arsenic, grey arsenic, black arsenic. Antimony is in blue white antimony, yellow black antimony. Oxygen is in dioxygen ozone. Sulfur is in rhombus sulfur, monoclinic sulfur. Selenium, red selenium, grey selenium, like that. Tellurium is amorphous and crystalline, okay, like that. So there are different forms that are the allotrophism. Now group 13 elements. Okay, group 13 elements, so the physical properties, their occurrence, their chemical properties, their formation of metal borides, like that we will see here. Okay, first of all boron. For boron, the boron occurs mostly as borates. Okay, boron mostly occurs as borates. So the important ores of borax is Na2, B4O5, OH4, 8H2 and kernite. So the boron occurs in different forms such as borax and kernite. Aluminium is the most abundant metal and occurs as oxides and also found in aluminosilicate rocks. Okay, அது வந்து போராக்ஸ் அப்படின்னு ஒரு காம்பவுண்டாக இருக்குது, அல்லது கர்னைட் அப்படிங்கிற ஒரு காம்பவுண்டாக இருக்குது. அதை என்ன பண்ணுறாங்க, ஃபர்தர் ப்ராசஸ் பண்ணி கடைசியில் போரான் கண்டுபிடிப்பாங்க. தட் இஸ் த அக்கரன்ஸ். ஓகே, போரானாவே நமக்கு கிடைக்காது, போராக்ஸாக கிடைக்குது, கர்னைட்டாக கிடைக்குது. ஸோ ஃபர்தராக அதை நம்ம ப்ராசஸ் பண்ணி நம்ம என்ன பண்ணணும், மாற்றணும். ஓகே, பாக்சைட். What happens, sometimes aluminium is a most abundant metal, but it occurs in the aluminium oxide form. Okay, it is also found in aluminosilicate rocks also. Okay, so commercially it is extracted from chief ore of aluminium is bauxite. Okay, Al2O thrice 2H2O, that is the chief ore of aluminium. The other elements of this group occurs only in trace amounts. Okay, the other elements, gallium, okay, tin, like that, they are the sulfides. And further the physical properties are also given. Okay, the physical properties are given. Okay, what is the physical properties? What is the physical properties? Okay, the physical properties are solid. Boron வந்து போரானோட physical property means அதோட physical state, அது solid-ஆ இருக்குமா, or it may be liquid or it may be gas. Okay, we will tell one by one. Boron is in solid state, aluminum is in solid state, gallium also solid state. Okay, what are their atomic numbers? Okay, atomic number, boron atomic number 5, aluminum atomic number 13. This table you should remember. Okay, and gallium atomic number 31, indium atomic number 49, thallium atomic number 81, and their isotopes are, isotopes means power la kuduthirupanga 11B, 27A, like that. Atomic mass is given, and electronic configuration is given, atomic radius is given, density is given, melting point. In the melting point kuduthitona solid வந்து liquid form க்கு மாறிடும். Further melting point, boiling point kuduthona gaseous form க்கு மாறிடும். Okay, this is the melting point and boiling point. Now the chemical properties of boron. chemical properties of boron. Okay, so boron is the only non-metal in the group. Okay, and the group laye 13th group la one non-metal irukku, that is the boron. It is less reactive, so it is very less reactive. However, it shows reactivity at higher temperature. When we give very high temperature only, the reaction starts. Okay, otherwise it is less reactive. So many of its compounds are electron deficient and has unusual type of covalent bonding due to the small size, high ionization energy and similarity in electronegativity with carbon and hydrogen. Okay, now formation of metal borides. Formation of metal borides. Many metals except alkali metals form borides with the general formula MXBY. Okay, up to 11 to 66. Okay, so direct combination of boron. What happens? See your book, page number 32. Page number 32. Direct combination with boron. Okay, Cr, that is chromium reacting with boron. N means the number 1, 2, 3, 4, like that, anything you can put. Okay, what happens? At 1500 degree Kelvin we are heating, it becomes Crb. Now reduction. Reduction, what happens? Boron trichloride, BCl3. So boron trichloride with a metal, okay, with a metal by dihydrogen, it gives metal boride. It gives a W is a metal. Okay, the metal is not given, W is, you can take it as a metal. We will get metal boride. W is a metal, B is a boride, metal boride. Now formation of hydride. See the equation, 2BF3 plus 6NaH. So the boron does not react directly with hydrogen, BF3. However, it forms a variety of hydrides called boranes. The simplest borane is diborane, that is B2H6. That is B2H6. Okay. Next, formation of trihalides. Okay, 2B plus 3X2, 2BX3. So halides is represented as X. Halides is represented as X. Okay. Then formation of boron nitride. Formation of oxides with boron. Okay, formation with reactions with acids and alkali. What happens? Like that. Okay, sodium borate is formed, boric acid is formed, sulfuric acid, nitric acid is formed. Okay, now what are the uses of boron? Uses of boron. Boron has the capacity to absorb neutrons. You should study the uses. Okay, very important. Boron has the capacity to absorb the neutrons. Okay, hence its isotopes is used as a moderator in nuclear reactors. Next, amorphous boron is used as a rocket fuel igniter. Amorphous boron is used as a rocket fuel igniter. Next, boron is essential for cell wall of plants. In plant cell wall is also boron is essential. Then compounds of boron have many applications. Okay, many applications. For example, eye drops. Eye drops ஊத்துவாங்கல, antiseptic மருந்துகள், washing powders, okay, that contain boric acid and borax. So in manufacture of Pyrex glass, boric acid is used. Okay. Next compound is borax. Next is borax. Okay, borax is a sodium salt of tetraboric acid. Okay, it obtained from colimate ore by boiling with sodium carbonate. Boiling with sodium carbonate. Okay, it is normally formulated as Na2B4O7 10H2O. It is a complex. Okay, it contains tetranuclear units. Okay, this form is known as prismatic form. This form is known as prismatic forms. Okay, the properties are borax is basic in nature. Okay, borax is basic in nature and its solution in hot water alkaline. What happens on heating with transparent borax? What happens when treating with ammonium chloride? What happens? The reactions are given in your book. Okay, you go through it. Okay, children. Now, what are the uses of borax? Borax is used for the identification of colored metal ions. Colored metal ions. Metal ions oda color identify பண்றதுக்கு borax use ஆகுது, and it is used in the manufacture of borosilicate glass. Okay, opticals. Okay, for spectacles, for wearing spectacles, and the enamels for that doors, etc. Okay, for pottery making, this borax is used. Okay, it is used as a flux in metallurgy. In the first unit you have studied about metallurgy, that flux. Okay, it is also used as a flux. What borax is used as a flux, also used as a preservative. Okay, preservative. Okay, next, see here, this is boric acid. This is boric acid. Okay. Now, this boric acid is prepared, okay. Boric acid is extracted from borax and colemite, okay. Take borax and take colemite and the reaction is further happen and further boric acid H3BO3 and further H3BO3, that is also boric acid, that is formed by borax and colemanite, that element, okay. The properties means the boric acid is a colorless transparent crystal. It is very weak monobasic acid. It is a very weak acid, okay. Very weak acids, okay. Now the action of heat, okay, it is heated at 373 Kelvin, okay, and metaboric acid is heated at 413 Kelvin. It gives tetraboric acid, okay. The equations are given in your book, okay. At 373 Kelvin what gives and 413 Kelvin, and for red hot, romba hot kudutona what happens like that. Now if it actions with ammonia, acted with ammonia, like that fusion of urea, okay, with boron in the atmosphere at ammonia 800 to 1200 Kelvin, it gives boron nitride, okay. Next, ethyl borate test. When boric acid or borate salt is heated with ethyl alcohol in the presence of concentrated sulfuric acid, an ester or triethyl borate is formed, okay. Now formation of boron trifluoride. Formation of boron trifluoride. See here, this is the structure of boric acid. The boric acid has a two-dimensional layered structure. See the structure, it is a two-dimensional layer. It consists of BO3 3 minus unit, okay. They are bonded by hydrogen. Hydrogen irukku, oxides irukku, boron irukku. Combination of 3, okay. What is the uses of boric acid? Boric acid is used in the manufacture of glasses, enamels and pigments. It is used as an antiseptic and eye lotion. Okay, eye lotion is also used as a preservative. Boric acid, borax, like that. Every one are maximum used in antiseptic, eye lotion, food preservative, like that. Okay. Next one, Diborane. Okay, this is also the types of boron, okay. Boron group lo ulladha, okay. Diborane. What happens in diborane? How the diborane is prepared, okay. See here, this is the structure is given. The structure of diborane is given. In diborane, 2 pH2 units are linked by 2 bridged hydrogen. See, sp3 and 2 bridged hydrogens are given. BH bonds, okay. It has 8 BH bonds. 1, 2, 3, 4, 5, 6, 7, 8. 8 BH bonds are given. Okay. However, diborane has only 12 valence electrons. And are not sufficient to form a normal covalent bond. So, the 4 terminal BH bonds are normal covalent bonds. Remaining 4 electrons have to be used for the bridged bonds. 2 3-centered BH bonds are there. See, these bonds are 3-centered 2 electron bonds. Okay, this is the structure of diborane. It is reacted with air. And reacted with alkalines and alkynes, reacted with metal hydrides, and reacted with excess ammonium. What happens? Okay, you should go through the equations. Next, boron trifluoride. Okay, the diborane is very useful as a reducing agent. Okay, reducing agent use aaglam. Next, it is used in welding the torches. Okay, torches welding, and it is used as a high energy fuel for propellant. Okay, now boron trifluoride. Okay, it is a it has a planar geometry. Okay, it has a planar geometry and it is a electron deficient compound because it accepts the electron. To form the covalent bond. Okay, form the covalent bond. Okay, next, uses of boron trifluoride. Boron trifluoride is used for preferring HbF4. Okay, that is a catalyst. Okay, in organic chemistry, and it is used as a fluorinating reagent. Okay, Next, aluminium chloride. Okay, aluminium chloride. This is a anhydrous aluminium chloride. It is used as a catalyst in Friedel's Kraft reaction. That is a reaction. Okay, and MCFE process also. We can obtain aluminium chloride by heating the mixture of alumina and coke. Alumina plus coke. Okay, in the presence of chlorine, we can get aluminium chloride. Okay, when aluminium metal or aluminium hydroxide is treated with hydrochloric acid, aluminium trichloride is formed. Okay, the reaction mixture is evaporated to obtain a hydrated aluminium chloride. Okay, it is used for the manufacture of petrol. Manufacture of petrol, aluminium chloride is used. It is used as a catalyst in the manufacture of dyes, drugs and perfumes. Okay. Now, alums. What is the alum? The name alum is given to a double salt of potassium aluminium sulfate. Double salt of potassium aluminium sulfate. So, nowadays it is used for all double salts. Okay. Univalent metal ion, trivalent metal ion, the potash alum, sodium alum, ammonium alum, chrome alum are there. Okay. So, alums in general are more soluble in hot water. That are soluble in hot water than in cold water. Okay, and in solutions they exhibit the properties of constituent ions. Okay, and solutions they exhibit the properties of constituent ions. Now let me tell the preparation. Okay, the alunite, the alum stone is the naturally occurring form and it is K2SO4, Al2SO4 thrice, 4AlOH thrice. Now, when alum stone is treated with excess sulfuric acid, okay, and excess aluminum hydroxide, it is converted to aluminium sulfide. Aluminium sulfide. The properties of potash alum is, it is white crystalline solid. It is white crystalline solid. It is soluble in water and it is insoluble in alcohol. Okay, so the aqueous solution is acidic due to the hydrolysis of aluminum sulfide. Okay, in this reactions there are lot of elements which are mingled with each other. Okay, if we give 500 Kelvin, it will give another compound. If we give high red hot flame, okay, high temperature, it will give another form. So the potash alum forms aluminum hydroxide when treated with ammonium hydroxide. Okay, now let me tell the uses of alum. It is used for the purification of water. Okay, in your home there is a water purification, isn't it? So in water purification this alum element is used. Okay, it purifies the water. It is used for waterproofing and textiles. Okay, in cloth textiles. Okay, in cloth textiles it is used for waterproofing, etc. It is used in dye industry. Okay, dye industry, paper industry, leather tanning industry, etc. It is also employed as a styptic agent to arrest the bleeding. Okay, arrest the bleeding. It is used as a styptic agent. Okay, in barber shop sometimes the blood comes, no, then they will make that or solid irukkum pathirkingla, that is in white color or kal madri, that is alum. That is the alum. Okay, it will arrest the bleeding. It will arrest the bleeding. Okay, that's all children. These are about borax. Today we have seen. Okay, tomorrow we will see group 14 element. Okay, group 13 element, that is called the boron group element. Boron group element la நம்ம என்னெல்லாம் பார்த்தோம்? Physical property பார்த்தோம், chemical property and அதோட uses. Okay, first of all எதை பற்றி பார்த்தோம்? Boron பற்றி பார்த்தோம். Next borax and next boric acid பற்றி. Next what? Diborane and next boron trifluoride. Okay, and aluminium chloride alums. Okay, 13th group elements patti paathutom. Then tomorrow, okay, we will see about the next day. Okay, we will see about group 14 elements, that is the carbon. Okay, very important topic. Okay, okay children, that's all today. And today's homework, you should write 10 one words from the topic up to page number 40. Okay, page number 26 to page number 40. Okay, go through and write 10 one words. Okay, and write the anomalous properties of the first element. That is a 5-mark question. Okay, anomalous properties of first elements, page number 29 and 30. Okay, and allotrophism in p block elements, there is a table, no, page number 30, there is 5 points, 5 lines and the table you study. Okay, write it down 10 one words in your homework note, and these 2 questions you write it in your classwork note. These 2 questions you write it in your classwork note. Okay children, that's all today. Study well, stay safe in your home. Okay.